Let's see. So let me find the pen. All right, so let me start writing. So this is the formula for the population growth. So capital K is the capacity times initial population P sub 0. We have to divide by P sub 0 plus K minus P sub 0 times e to the negative r times t. So this is the one I use for this problem. So in the question, you're supposed to know the capacity. Capacity is given, right? K is the capacity. P sub 0 is the initial population, right? R is the reproduction rate. It's not given, but you will have to find it using the information that that the initial population doubled, right, after a certain number of hours. Am I correct?
Right.
Yeah, so so basically you would need to plug in your numbers in here, right? Twice P sub 0. So I don't know what was the population after how many hours did it double?
Let me take a look real quick. Mine says 13 hours.
Right, so if you know that the population doubled after 13 hours, so you would have to plug that into this equation. I'm sorry, this is plus, and then K minus P sub 0, E negative RT. So you should be able to solve this for the birth rate R, reproduction rate, right? You can find it, and once you have that, you should be able to find population after a certain number of hours. Okay?
So for these types of questions, when they say the initial doubles, we don't have to substitute the values. We can just cross P initial from the beginning.
You can. Yeah, that would save some time. Yeah.
And then also, when you ever give us the values in thousands, do we have to not plug it in, you know, in the 1,000 values, or?
It's up to you. It depends on, well, if your numbers look really long, I would just, instead of writing thousands, I would, instead of writing the entire long number, I would just write the number of thousands. So in other words, if P sub 0 is given as 15,000 members, right? 15,000, that's a long number. I wouldn't do that. I would say 15 in thousands. And then I would use 15 for my computations. The problem could happen when it's time to write your answer. When it's time to write answer, make sure to multiply by 1,000, right? Whatever number you have, you will need to multiply it by 1,000. Does it make sense?
Yeah, thank you.
You're welcome. All right, any other questions? All right, so one more time, you still can attempt one more time quiz number 3. It will be closed at 11 p.m. tonight. So you have until 11 p.m. if you want to. If you don't want to take it, that's fine. If you're happy with your current grade, you don't have to do anything. Quiz number 4, I believe it will be available tomorrow morning. Let's see, are there any questions on your homework? Any questions on your homework?
I actually had another quiz question.
Quiz question?
Yeah,
Which one?
but before that, just for this part, would you cross multiply to solve for your R? Is that the easiest way?
Oh, it's the same problem, right?
No, it's not the same one. I just had a quick question on this one. Like when you want to solve for R, would you just cross multiply? Is that your easiest way for this part?
Yes, you can cross multiply.
Okay,
Or
and then
yeah. Mhm.
and then I had a question on the gallons problem. You gave us like I think it was 1,000-gallon tank, and then you gave us like a certain amount of gallons in mixture. So I had trouble with that because I think I was getting the wrong rate out.
Rate out. Isn't it true that the volume remains constant? So the mixture enters, I don't remember the numbers, but the mixture enters at the same rate as it exits from the tank. So again, I don't remember the exact numbers, but I believe the volume of the mixture doesn't change.
But would your rate out be like the amount of mixture gallons plus your rate out T, or would it just be your rate out?
I'm not sure. It's going to be rate in. Let me write it down. So dx dt. It's possible we're confusing. So dx dt. This is normally how we do it. We say rate in minus rate out. This is how we build the equation, right? So rate in is usually it's just a constant. So we multiply how many gallons per minute times concentration, right? Concentration, let's say, I don't know, certain number of pounds per gallon, right? And from there you subtract, rate out is usually, let me clear that quickly. So, okay, let's see, oops.
Because I still have the question if you want me to give you the values.
Yeah, it's okay. I'll just continue. Yeah, that's okay. So x of t over volume, right? Volume. This is normally how we build the equation. Dx dt, change in the pounds of salt in the tank, rate of change is, and then we have rate, oops, what's happening? So rate at which mixture enters, so that's number of gallons per minute times concentration, number of pounds per gallon. And then from there we subtract number of gallons per minute that exits, and then x of t is the amount of salt in the tank, which is changing, divided by the volume of the mixture. So the thing is, R1 and R2, the way the problem is set up, those are two equal numbers. Those are equal. You're supposed to have the same rate in and rate out, which makes life easier because the volume of the mixture in the tank is constant. So volume is going to be constant. It doesn't change, again, because the number of gallons that enter is equal to the number of gallons that exit the tank. So that means the volume is constant. This is always a better case when you have constant in the denominator instead of a function. Does it make sense?
But for the volume on the denominator, are we going to do the amount of gallons mixture plus your rate out on the bottom, or is it just going to be the mixture of the gallons amount?
The number of gallons in the tank, which is constant. And it's not 1,000. It's whatever you have in the tank initially.
Oh, so if they give you a total tank in gallons and then they give you the mixture, we're just going to put the mixture for volume.
Right. This is the volume of the mixture.
Okay.
Of the mixture.
then why in our notes, some examples you would have like 300 plus 2t, for example, you'd have like the net rate in the denominator with the mixture of the tank.
Well, that happens if these two are not equal. If R1, see in this example on the quiz, the rates of the number of gallons that enter and the number of gallons that exit, those are equal in the quiz. But sometimes if they're not equal, if R1 is not equal R2, then the volume in the mixture in the tank, the volume of the mixture in the tank is not constant anymore. It's not constant, it's going to change. So that's how you might be getting some function, something like 300 plus 2t, or it depends on what the numbers are.
Okay, and then whenever we have different rates, that 2t part, is it just the rate of outflow or is it the rate of outflow minus inflow?
It's the difference of rate in minus rate out, gallons per minute.
Okay.
All right, oops. Any other questions here? Any other questions? So again, please make sure to copy from the screen because I'm not sure whether I'll be able to post this. It's a little complicated, at least for me. So any other questions here? Or on your homework? Are there any questions on your homework? We did section 4.1, right? 4.1. On Thursday last week, we completed this. So are there any questions on 4.1? Okay, so the plan is to get started with 4.3. So we'll talk about section 4.3, linear homogeneous equations with constant coefficients. So let me start writing 4. Let's see. So okay. (4.3) again, linear homogeneous with constant coefficients. So linear homogeneous differential equations, DEs, with constant coefficients. All right, so we're going to focus, these are the most simple ones, and you will see that these problems are very straightforward. So let's take a look. This is the type of equation that we will discuss. So y double prime plus p times y prime plus q times y equals 0. So first of all, did you notice these are homogeneous, right? The right-hand side is 0. Do you agree?
Yeah.
Excellent. So the first step is to build the characteristic equation. So let me write it here. The characteristic equation. So please notice how I'm going to build it. So I'm going to replace y double prime with lambda squared plus p times lambda and plus q. So this is called characteristic equation. Keep in mind here, P and Q are constants. Those are just numbers, are constants. All right, so again, what happened here? Y double prime, the second order derivative, was replaced by lambda squared. And y prime, the first order derivative, is replaced by lambda to the power 1. And y is not replaced by anything. It's just going to be just 1. Does it make sense?
Yes.
Excellent. So let us try to build a characteristic equation for, let's see, example. So here is the differential equation, y double prime minus 3y prime plus 2y equals 0. So please tell me, what is P and what is Q?
Negative 3 and 2.
P is negative 3, am I right? And Q is, let me see, the Q is the number in front of Y, right? So this is 2. So now tell me, what is the characteristic equation? Help me to build it.
Lambda squared
Yes?
minus 3 lambda plus 2.
Excellent, there you go. So this is the characteristic equation. Perfect. So the reason we want to know how to build a characteristic equation is this is the equation that will tell you what the solution is. So there are 3 cases. Here is the first case. Let me, and by the way, the equation itself, what kind of equation is this?
Quadratic.
Quadratic. This is a quadratic equation. So there could be 2 solutions, right? 2 real solutions. There could be 1 repeated solution, or there could be complex solutions, right? So there are 3 possible cases here. So let us write down case 1. Case 1 is if p squared minus 4q is greater than 0. In this case, there are 2 distinct real roots, lambda sub 1 and lambda sub 2. So then there are two distinct real roots, lambda sub 1 and lambda sub 2. Well, in this case, a fundamental set of solutions, a fundamental set of solutions is y sub 1 equals e to the lambda sub 1 t, and y sub 2 equals e lambda sub 2 times t. So if this is a fundamental set, then we know what general solution looks like, right? So then general solution will be, linear combination of these two. So it will be y equals c sub 1 times e lambda sub 1 t plus c sub 2 e lambda sub 2 times t. All right, so that was case 1. Let us practice with this. Let us practice. So I'm going to return back to that equation. I believe, yeah, this is case 1. Let me double check. Yes, this is case number 1. So let's take a look again at this example. I'm going to go over here, and we'll look at again at the same differential equation: y double prime minus 3y prime and plus 2y equals to 0. So we will try to solve this homogeneous differential equation. Once we find the general solution, we want to, after that, we want to find particular solution that satisfies y of 0 equals 2 and y prime of 0 equals 1. All right, so first step is to build the characteristic equation, and we already did that earlier. So again, replace y double prime by lambda squared minus 3 lambda plus 2 equals 0, right? So this is the characteristic equation, and we're going to try to solve it. Let's find two numbers so that product equals 2 and sum equals -3. So what should we write over here? What are the two numbers? What are the two numbers to put here?
-2 and -1.
Thank you. Let's check. So we have lambda squared minus lambda minus 2 lambda and plus 2. Excellent. Thank you. Very good. So yes, we're getting two real solutions. Lambda sub 1 is 2, lambda sub 2 is 1, right? So two real distinct real solutions, real roots. Distinct real roots. I don't know why does it do that, real roots. So any questions so far? Any questions? So again, the first step is to build the characteristic equation, find the roots. In this case, we have distinct real roots. And since we have distinct real roots, a fundamental set of solutions is given right here, right? This is the fundamental set of solutions, y sub 1 and y sub 2. So let me copy that here. Y sub 1, therefore, is e to the 2t, and y sub 2 will be e to the t. So this is a fundamental set. Okay, so that implies our general solution, y of t, will be linear combination of these two fundamental solutions. So it's c sub 1 e to the 2t plus c sub 2 e to the t. So we have general solution. Do you agree so far?
Yes.
Okay, excellent. And now let's take a look at those two conditions, the initial conditions. Y of 0 equals 2. Let's start with this one. Y of 0 equals 2. So y of 0 equals, well, this is e to the 0 here, e to the 0, and supposed to be equal to 2. Very good. So let's see. So far, we have this equation, c sub 1 plus c sub 2 equals 2. We need the second condition, right? Y prime of 0 equals 1. Y prime of 0. To find y prime of 0, we first have to find y prime of t. Okay, y prime of t, the derivative of the general solution will be 2c sub 1 times e to the 2t plus c sub 2 e to the t. This is the derivative, y prime, and we're going to plug in 0 in there. So y prime of 0 is 2c sub 1 e to the 0 plus c sub 2 times e to the 0. and it will be equal, we said it's supposed to be equal to 1. Okay, let's see, 1. So yes, we have system of two equations. This is the first equation that we obtained earlier. And the second one is 2c sub 1 plus c sub 2 equals 1. So we will solve this for the constants. And I will start by, there are different ways to solve it. You could do elimination. It seems easy to eliminate here. Or you can use substitution. I'll use substitution here. So I'm going to say c sub 2 equals 2 minus c sub 1 and substitute into the second. Okay. So I'm going to combine the like terms here. So that would be c sub 1. And from there, c sub 1 equals -1. So from this relationship here, I'm getting c sub 2 equals 2 minus c sub 1, which is -1. And I'm getting 3. So any questions?
Yes.
Yeah, Professor. Can you just scroll up a little bit to the beginning of the problem?
Yes, is this good?
Yep. Perfect. Thank you.
You're welcome. All right, very good. So any questions, please let me know. Any questions? So yes, we have our two solutions. So this is the general solution up here. Y of t equals c sub 1 e to the 2t plus c sub 2 e to the t. So we found the constants. So let's write the general solution. So c sub 1, and we said c sub 2 is 3. So this is what I'm getting for the particular solution. All right, do you have any questions? Do you have any questions? So this function satisfies the differential, the initial value problem, right? The entire initial value problem up here. Any questions? Okay, so let me see if I can, that's strange. I cannot seem to make it scroll higher. Does it have limitations for length? I'm trying to scroll it down, but it doesn't go any further. All right, so let me try to continue with this. It's strange, why it's not moving any further? I can scroll up, but I cannot scroll any further down. So the next case would be, yeah, it doesn't let me do it. Let's see. I guess I'll have to start a new file. Oh, that's weird. Okay, so let me continue with case number 2. This is the case when p squared minus 4q is exactly equal to 0. In other words, we're getting repeated root. So the characteristic equation has one repeated real root lambda. Then y sub 1 of t will be e to the lambda t, and y sub 2 of t will be t times e to the lambda t. E is the fundamental set. Okay, so we have fundamental set. This time it will look like this, and the corresponding general solution will be linear combination of those two functions. So this is general solution. All right, so let us try to use this now. Let's take a look at an example. So example will be let's look yeah, let's try this one. So example, all right, here is the differential equation and the corresponding initial conditions. All right, So I'm going to give you a few moments to try to find the characteristic equation and the corresponding characteristic numbers. You're supposed to get one repeated root. And once you get that root, try to use, I'm just trying to understand this, why it's, what is this circle in the corner? I'm trying to figure out what is this circle right here? What is it for? Okay, so again, please try characteristic equation. I'm going to start breakout rooms. Don't be shy, please talk to your classmates. There will be only 3 breakout rooms, okay? So everybody should try to first find characteristic numbers, find the general solution, and finally find the particular solution, okay? So let me open the rooms, please join. And again, we're working on this, this initial value problem here, okay? So again, please join.